Okay, I don't know, sleep deprivation catching up with me or something, but after we get everything straight, I write down what I want to write down, which is that this matrix decomposes into a lower and an upper triangular matrix, and there they are. Okay? And we can verify it, that this matrix, which is this one, multiplied by this matrix, which is this one, gives us this matrix, right? Now why should that be? Well, it's because if I multiply, let's be sure I multiply right one, if I multiply well, E2, E1 times this, I get this, okay? So, what's this? This is E2, E1 times the 1, 2, negative 14, and give myself more room. Okay, 2061 is your E2, E1 inverse, right? Okay? And this is this. This is very simple. Just trying to keep it straight. Of course, I've been here since 9:30 talking to people. I have all kinds of excuses, but there's no excuse. It is what it is. Okay. So, I mean, this matrix is what we get when we do E1 times this and then E2 times that, right? Which is E2, E1 times our original matrix. And we've seen that's upper triangular. Why is that upper triangular? Because that's what we did. We reduced this until it was upper triangular, and then we stopped. Okay? And this is just E2, E1 inverse. So what I've stated here is just the obvious that 2, 4, 6, negative 2 equals 2, 4, 6, negative 2, because all this is just the identity, right? Okay? I actually said that right. Is it clear? So it's actually kind of a simple scheme, isn't it? It still gives people trouble, especially when you start trying to use it, and that's our next step. So again, have that to look forward to. Let's see if I do that right. Okay? How about I got it all written down right for your homework? Yeah. I think I'm already close. So how did I write it down? I can't say it now. Okay, so you see what we've got, right? Well, let's see how we can use this to solve a matrix equation. So let's keep this here so we can refer to it. And let's look at solving the matrix equation 2, 4, 6, negative 2 multiplied by xy equals 5, 17, whatever. If you don't like those numbers, tell me two others and I'll use them. Okay? Make sense? Okay, well, I can rewrite this in terms of my lower and upper triangular matrices, right? Now there's an advantage doing this symbolically and there's an advantage doing it with numbers. I'm not sure this is the best way to do it, but we're going to do it this way anyway. Then I'll write it out symbolically because it'll work in general for any matrix equation with square matrices, okay? Okay? Well, so, yeah, if we understand the decomposition, if we believe what I just wrote here, that's what we have, right? And we can verify if I multiply this, we get this, we already did. So if I've written down the right matrices, which is questionable, this should work. Okay? So, well, I'm going to say, okay. just solve this. What's this mean? X plus 2y equals 5, negative 14y equals 17. Okay? Now, just to keep things from getting out of hand with fractions, which I think I can do, given everything else, I change that 17 all the way up here to a 14, which will give us a nice simple expression for y. And then, even though our expression for x will be a fraction, it won't be as ugly as it might have been. So when I said you could give me an easier number, I know everybody wanted to say 14, but okay. So here we have the equivalent system, right? Well, that's easy to solve. Backward substitution. Y equals negative 1. Put that back in here. And we get x plus 2 times negative 1 equals 5. X equals 7. Okay? Okay, so 7, negative 1 solves this. We can verify it. Well, solves this, not this. Okay? Okay, if it's 7, negative 1, then we get 7 and negative 2, which is 5. And we get negative 14 times negative 1, which is 14. No big surprise. Okay? Okay, well, now we've got that solution. What do we do now? I think we can get rid of this. Well, now, so solution to this is xy equals 5, 7, right? 7, 5, sorry. Well, 7, negative 1. Okay? And I did this backwards. Okay? It doesn't get us anywhere. But it was fun. Okay? We're going to do it right now. Okay? We're going to get ugly fractions, but I'm not going to change numbers on you again. Okay? That's easy to solve, isn't it? Okay? Well, this means 2a equals 5, and 6a plus b equals 14. Right? Which means then that, okay, a equals 5 halves, right? So we plug that in here. This is just forward substitution. And we get 6 times 5 halves plus b equals 14, so that b equals what? Well, 6 times 5 halves is 15. 14 minus 15 is negative 1. Okay? Okay, so that's going to work as long as this, as long as xy with this matrix gives us our 5 halves negative 1. So I'm going to say, so 1, 2 multiplied, or 0, negative 14 multiplied by 5 halves negative 1. No. Multiplied by xy. Write things down without thinking, equals 5 halves negative 1. Because if that's so, if xy is a solution to this, then this would be 5 halves negative 1, won't it? So when we multiply it by this, we get 5/14, right? Kind of slick. I just, never mind what I did. Okay. Make sense? So that's easy. You know, this is x plus 2y equals 5/2. Negative 14y equals -1. So that y equals 1/14. Right? And now we got 2/14. And we got 5/2, that's 35/14, right? So I think we get x equals 33/14. Okay? And see, that's easy. Even though the fractions are starting to get a little ugly and I might have screwed it up, you can fix it. Okay? It's easy because I'm just solving two triangular matrices, equations with two triangular matrices. And triangular matrices are always easy. Now, if you're just trying to solve this equation right here, and that's all you're trying to do, you probably don't want to go to all the trouble of doing the LU decomposition. LU meaning lower triangular times upper triangular. So, you know, this is what I mean by LU. Here's L, here's U. Okay? You solve L times something equals 5/14 and get that solution and set that equal to this times xy. Right? Kind of makes sense? Because it is a little confusing when you first read it like in the book. So you want to really have this picture down. Okay? So being able to do an LU decomposition is kind of pretty neat thing to do early in a course. Okay? There are other decompositions, most of which I don't know, because you know, haven't made use of the deep linear algebra. But I can see how they come up. Not sure I could reproduce them without looking at some steps, because it's fairly complicated. Much more complicated than this. Okay, so anyhow, you know, there's no limit to depth in a linear algebra course.